Hello, in this video, I'll talk about why pulling a roller is comparatively easier than pushing it, though it has same weight during both the time whether we are pulling it or whenever we are pushing it. So then what makes it impact? Like what creates the difference why the pulling roller becomes easier than pushing it? I'll show you both the cases quickly. So let me draw the cross section of the roller. So these are the cross section of the roller and I'll take one by one cases. So let me draw the bar along which the forces we are applying. Let's first take that we are, let's first consider the case of pushing a roller. So if we are pushing it, which means the force whichever we are applying along the handle will be in this direction. So I'll mark it. So whatever force we are applying, F will be directed along this line, right? So this is the F which we are applying, and the weight of the roller will always be acting downward, right? So this will be mg if m is the mass of the roller. Now we can break this component into two. So if this is the force that we are applying along the handle, now we can break it into two components. One will be the component which will push it forward. Okay, let this angle be theta. And if this is F, so this will be F cos theta, right? And the other component of the force which we are applying will go in increasing the weight, effective weight of the roller. So this somewhere along this will be F sine theta. So here we can see that the net weight or effective weight of the roller will be mg plus F sine theta. And because of this additional weight or additional force which the roller is experiencing from the top, F sine theta, which makes it more harder to push it. Clear? Now let's see the pulling case of a roller. Again, the same, I'll draw the handle along this. Now we are applying force along this direction. And this is the force acting downward. Let this be mg. So if this is mg, and this is the force which we are applying on the roller in pulling it, so this is the F. So it will have again two components. Let this component be, this component will be F cos theta. This is the angle theta with the force is making with the horizontal or with the ground. So this is F cos theta. Then other component will be F sin theta, right? Now in this case, apparent weight of the roller will be mg minus F sin theta. And you can see that the effective weight of the roller in this case, when we are pulling it, it got reduced. And this is because of that reduction in the effective weight of the roller, which makes it easier to pull it. While when we are pushing it, it get additional force from the top. The component is F sin theta. So there's additional F sin theta, which will increase the effective weight of the roller, which will make it more tough to pull it, to push it. So it depends, shall we pull it or shall we push it? It depends what the work that you want to do it. So if you want to press it harder against the ground, if you want to level the soil or grass, whatever. So in that case, you see whether you need to apply more force, it requires more weight to level it, then you, in that case, you need to push it. If you want a lighter press, then you pull it. I hope that is clear.